So good morning. On behalf of the Flemish government, a warm welcome at the Interoperable Europe session from cloud to edge. In fact, we are here on a historical location. In '57, the first meeting of the predecessor of the European Commission was held here. You can see that it's a historical location because there are still ashtrays on the desks and there's a bottle of whiskey in the left drawer. So I would like to introduce you to our speakers. On the left hand we have Vivi Lartunoia from My Data Global. We have Professor Steven Lattre from IMEC and Dr. Cesc Wem from OpenChip. Welcome. Now, we are surrounded by a lot of edge devices, probably in a perimeter of 100 meters, it could be several thousand. These edge compute devices entered our life at lightning speed. For instance, we have here a Roomba vacuum cleaner. It's from the Amazon family, and I don't know whether it's vacuums more dust or data in our homes. And we have several disruptors on the level of edge compute. First of all, we have the technology. For instance, our cars have become mobile data centers with AI capabilities that are far over the edge. Second of all, we have a lot of challenges on the level of privacy because our data is streamed to the cloud of the GAFAs and GAMAs. It introduces a lot of problems both on the level of transparency and privacy, but also on the level of innovation because our data is locked in their silos. And last but not least, we have a lot of geopolitical challenges in Europe, and because of the edge devices that collect a lot of data and stream it to the clouds, our infrastructure has become very vulnerable. Now, it didn't happen suddenly. We have a lot of things that happened in the past. For instance, on the level of compute, we started with our first personal computers in the 90s, I think. These were in fact edge devices. Then we went to the cloud, we went to AI, to IoT devices, and today we have a huge capacity of artificial intelligence, now centralized, but very soon decentralized on our mobile devices. Second of all, on the level of data, we started with static data, going to Web 2.0, going to the semantic web. A lot of you here in the audience are probably semantic web experts using linked data. This is self-describing. So we are now in a world of data tech. Last but not least, on the level of being connected, I still remember the time where I wasn't connected, and then we went from 2, 3, 4 to XG. So this brings us in a new world with edge compute as a new paradigm. And it's really a disruptor. It's everywhere. It's in our home, it's in our car, it's in our industry, and it's here to stay. And we face a lot of challenges. The first one might be a challenge on the level of the Green Deal. If I would say, Siri, can you switch the light off? And in 1 or 2 hours, I would ask Siri, can you switch the lights back on again? Then it would be a negative equation because the compute power sending my question to the cloud of the GAFAs, processing there my question with artificial intelligence and, if you want, large language models comes at a cost that that can be underestimated. So, for instance, when I generate a picture on DALL-E, it takes me the amount of energy to charge an entire iPhone. Imagine what the cost of streaming video is generated by artificial intelligence. So the Green Deal challenges on the level of the footprint of what we're doing with artificial intelligence. I will also address a second challenge, and it's on the level of privacy. The devices in our home, in our car, in our bike, they stream a lot of data to the cloud of the big tech. And then you have several lenses to look at this challenge. It could be the lens of Silicon Valley, where we have a minimum of governance by the government, and we leave a lot of the decisions with big tech. We could also look at a model of China, where the complete governance is at level of the government. Or we can look with the lens of Europe, where we look at a third part, where we put citizens in control of their data, whether it's in the cloud, on a pizza box, in a data center, or whether it's on my edge device. So there we have a lot of legislation being developed or already in place to give citizens or those who generate the data, which could be also businesses, give them more control. So I truly believe that edge should be sustainable. Think about the Green Deal. Should be, of course, intelligent, but should maintain our data sovereignty. And our speakers will zoom in detail on these huge challenges that we face, and they will come up with solutions as well, because we're here from research to reality to put the new solutions in place. And therefore, I would like to give the word and the floor to our first speaker, Vivi Lachnunoya. The floor is yours.
Let's see if this works. Excellent. And is there any chance we could get the slides on the front so I can see them?
No, the slides are not on the monitor. 1 second.
Just a second, thank you. Yeah, it's. I can also just stand up if that's easier, but then there's less mic availability. But I'll just start by introducing myself briefly. So thank you so much for the invitation, Ralph, to join the other expert speakers in this session. And the title of my talk, as you can see there, is why this is important. And that's something that I'm really, really passionate about. And I come at this question from a number of different directions. So here I'm primarily representing My Data Global, which is a non-profit, international non-profit association headquartered in Helsinki in Finland. We founded it in 2018 in response to a community of practitioners and experts and advocates and activists who were saying exactly what Raf was saying earlier as well, that people need to be in control of the data that they generate and is generated about them. So this is kind of one angle at which, from which I come to this thematic as an advocate, as an activist as well. But I do have other hats too. So my day job is a consultant. I'm a senior data strategist for a small Finnish consultancy. We're called 1001 Lakes. And in this role, I get to get really hands-on with how actual organizations, public and private, work with data and implement the kind of requirements that the new EU legislation is imposing on them, and also work on realizing the potential innovations such as data spaces that are coming out of the EU data strategy. And the third hat that I do wear as well is that of an academic. I'm a researcher. I'm currently with the philosophy department at the University of Helsinki, where I work on my PhD project, which is specifically around the ethics and moral philosophy of personal data. This is promising. Okay, let's see. Okay, so. Yeah, all right, that'll do. So I'm really grateful for the opportunity to kind of have this chance to talk to you about why I think what Raf is talking about is so important. How we deal with data, where we deal with it, and what we do with it. Why is it so important? Because when we talk about data, we always also talk about people. So. Whether it's, no, it's gone. Oh, we have a rough slides. Oh, I'm backwards. Yeah, sorry. Yeah, here we go. So whether we talk about IoT data or energy data or health data or public services and public sector data, the reason that data exists is because people are using these services, people need their services, people want these services, and that's how the data gets generated, right? So this is why fantastic. The data is there in the first place, right? Data is not the end goal here for anyone. It is a means to an end. And how we use it, where we use it, how we deal with it, like I said, it affects the real lives of real people in the real world. And this is why I care. I genuinely want to make the world a better place the best way I can, and I feel I can do that through data. I can help together with communities like this one, the world to become a better place through a better handling of data for people and by people. And so the whole point of my data is this kind of pretty profound, but still very, very simple core idea that individuals, people, should be in control of the data about themselves. So the roots of my data actually are in the open knowledge movement, where some people got together around 2012 at an open knowledge conference and started thinking about the data that we can't just make open. Data that is about people, that is private, that belongs to, and also business secrets, trade secrets, and things like this. What can we do to make use of this kind of data by kind of applying and adapting open data principles? And that's where the idea came from, of making personal data open, not to the world, but to the person about whom that data is. So this is where the vision comes from. And the approach is very much aimed at kind of strengthening digital human rights, while also opening up new opportunities for businesses and for public sector organizations, research organizations, to develop innovative personal data-based services that are built on a two-way mutual trust. And the profound importance of this approach, which Raf also contrasted with some other approaches that exist in the world, has been recognized very clearly by the EU. So in February 2020, the Commission put out the European Data Strategy, and they explicitly recognized my data as a movement that promises significant benefits to individuals, including to their health and wellness, better personal finances, reduced environmental footprint, hassle-free access to public and private services, and greater oversight and transparency over their personal data. This is a direct quote. This is what we're talking about. And so what is this in a little bit more detail? So the point is really what we want to see are fair and sustainable and prosperous digital societies. Not just one also, I always like to make this point that we're talking about plurality of societies that need to live together on this planet and also on this continent. We need these societies to function in a way where persons, people, get value from their data and they set the agenda for how that's used. And for organizations, the ethical use of personal data is always the most attractive option. And the ideal case and scenario is one where this kind of creates this virtuous cycle of reinforcing needs and offers, supply and demand. But obviously, this is not the society or these societies that we live in right now. Okay, so there's a bunch of stuff that needs to happen from now on. So the first thing is that we're in the EU, we're incredibly lucky to have things like the GDPR, like the Data Governance Act, like the Data Act, the AI Act, and so on and so forth, which codify certain formal rights for us as individuals, as consumers, as citizens. But what needs to happen is for those to become actionable, for them to become very, very easy for anyone to use, and therefore can also gain the benefits that are possible from, for example, the right to data portability, which is really the crown jewel of the GDPR, right? It was a completely new kind of a provision whereby I have the right to port the data that I have submitted somewhere to another service. And this is potentially incredibly valuable for me as an individual, but at the moment, the way that this works in technical terms, in business terms, isn't super easy, right? And we all know how human beings, how we are. We like things to be easy, cheap, fast, and just work seamlessly. We don't want to deal with data. We just want a service. We want it to work for us and solve a real problem for us. So this is the formal rights are absolutely necessary and the first step, and now we need to make sure that we can actually use them. The second shift that we want to see is going from data protection alone to data empowerment. Again, data protection, absolutely necessary. The bare minimum of any kind of civilized, digitized society is that you have to have basic rules for data protection. This is incredibly important in the world of surveillance that we're in and entering into, right? And on top of that, we need to be able to empower individual people, also groups and communities, to make the best decisions they can for their data and to generate genuine value, to prove to policymakers certain things that need to be fixed that affect their community. This is a real problem, especially for marginalized communities who don't have data collected about them. So it's hard for politicians to recognize the issues that they face on a daily basis, but because there's no data, it's hard to argue for why they should be fixed. So things like empowering communities and individuals and also the marginalized populations is an incredibly important part of how we get towards these fair, sustainable, and prosperous digital societies. And the final point here is moving from closed to open ecosystems. So this is essential, especially kind of from the organizational point of view of thinking about personal data. So we all know that it's a mantra in events like this to say, like, we need to break down the silos, and, you know, get data moving better, make it interoperable, generate more value from it. And this is really, really key. And the way we can collectively get the most out of data while respecting the rights holders of that data is through open ecosystems, such as, I would argue, the European data spaces will be. And let's see. So in even more kind of detail, what we as the My Data community have developed and published already in 2017 are the My Data principles. And these are the things that I would kind of encourage anyone designing services or other tools that make use of personal data to consider when they are working with people's data and with data that affects people. That's also an important distinction. We're not just talking about personal data that's strictly like within the parameters of the definition of the GDPR. What I'm talking about is data whose use actually affects people, right? So the human-centric control of personal data is the #1 point here. And also the second point, I think, is often misunderstood. It's the individual as the point of integration, which basically means that like we can get better quality data when we go through the individual. We don't have to haphazardly kind of try to match different kind of identifiers from different kinds of systems and different kinds of organizations and different kind of data sets when we go through the person. Through the person, we get data that is reliably theirs and with their consent or with other kinds of legal grounds for processing. Individual empowerment I already talked about, and then the other three, are a little bit more on the technical side, and they're kind of critical enablers for the first three. So we already have in the GDPR rights to portability, rights to access, and these are really key for reuse. And this is also relevant for the Green Deal that Raf mentioned as well, and goals related to that. If you don't have to recollect, restore, and reprocess data all over again, we can also reduce the carbon footprint of the entire digital industry. Transparency and accountability, hugely relevant, obviously, right now for in the age of LLMs and artificial intelligence, and interoperability are also mentioned as well. If we are to treat data in a human-centric way, where the human being is at the center or is the point of integration, we need all sorts of data from different kinds of systems, different kind of formats, different kind of vocabulary, semantics to interoperate for them to be able to serve the person. So this is my penultimate slide. To summarize, like this really matters because individuals need to be empowered, they need to be protected, and they need to have agency and control over the data about themselves. We can do this in a number of different ways, and you can also learn more about my data at mydata.org. But at this point, I think I will thank you and look forward to talking with you later on. Thank you so much.
Thank you very much, Vivi. I would like to give the floor to Steven.
Thank you, Raf. So I'm going to switch gears a little bit, going from data to AI and going from data to hardware, but you'll see very quickly how these three different domains very closely come together. So my name is Steven Lattre. I'm working for IMEC, which is a non-profit research organization working on semiconductors and digital technologies. I'm responsible there for the R&D on AI. IMEC is already 40 years old, originally started in Belgium, and already for those 40 years, we've been really at the forefront of semiconductor technologies, developing new type of chips, new type of transistors as well. All of these transistors that have, in the end, also led their way into what you typically have in a foundry, so where the large-scale chips are being made as well. Because of that, we've been able to really go towards drive Moore's law. And for those of you who are not familiar with Moore's law is essentially saying that every 2 years we're able to build chips that are twice as fast, twice as cheap in that sense, more or less at least. And that's the whole has been already for the last few years really the revolution of everything here, everything that Raf has been talking about on the reason that we now have smartphones in our pockets, which in the past occupied an entire room full of size, is really the driver for a lot of these technologies. And if you look at it from a more technology perspective or era perspective, we see that every so often we get a new kind of environment that comes up. In the 70s, we were talking about large-scale mainframes. In the 80s and 90s, we suddenly had the Pentium PC popping up, and we were all talking about personal desktop computers. more around 2000. Suddenly the mobile era started with smartphones and a lot of chips in this domain. And I think it's very clear right now that also from a hardware perspective, we're in this AI world right now. Certainly AI is also all about chips, and NVIDIA is the biggest technology company in the world because they're developing hardware for AI. But at the same time, for AI, it's also a bit of a dual thing. It's clear that Moore's Law has been driving a lot of these innovations together with software, but the evolution for AI has not been that exponential until now. AI has had moments where there was a lot of enthusiasm about it, but we also have had a lot of winters as well. Obviously, we're now very much in the summer, both figuratively speaking and actually speaking right now. But we're in this AI summer today that the hype is very, very, very big on AI. But we should not forget that in the past we had these AI winters, and it could occur that AI gets into a new kind of winter as well. And in order to see whether we will get into that winter or not, we need to check on what were actually the drivers in the past of these AI winters. There have been moments in the past where we worked a lot on, where there's a lot of enthusiasm on AI, but where the potential of that technology has not led to the breakthroughs. And there were actually three main reasons for that. One is lack of data. We didn't have the data back in the days that we have right now to train large-scale models. The second one was lack of compute. We could build the software around it, but the chips weren't fast enough. And then also lack of trust. We weren't really able to trust the system and be sure that the system was still having the same performance that we as humans would have as well. And obviously we're in this high right now of unbelievably great AI technologies, but to some extent we are also again facing maybe smaller triggers on this. We still have challenges in lack of data, lack of compute, and lack of trust as well. I think Vivi already explained quite well the lack of data. Data is often being put in silos, and it's not that easy to really unlock all of that. And there's privacy legislation, rules which should be there as much as possible. So we're moving into a world where data is being more and more distributed, where every user gets control over its own data. We should do this, but at the same time, that also puts a strain on what we can do with AI. So it's a very tricky balance to have this. And I think it's clear that we're really in an evolving world towards that. So just a few weeks ago, Apple launched its personalized AI model for now only in the States, not in Europe. And it really focuses on distributing data and making sure that your data is really in a private cloud for you itself. So we're seeing this trend on decentralized, distributed data, very much exactly what Vivi was just talking about as well, the need for personalized data vault. So I'm not going to dwell too much on the data aspect. I'm mainly going to dwell on the compute aspect of all of this. Because if you move from this more cloud-centric environment where data is essentially everywhere, all local to our own users in a kind of edge environment, from a compute perspective, it's going to be very complex as well. And it's going to be very important to build what we call PPACE environments. What does that mean? It stands for power, performance, area, cost, and environment. It means that we need to develop compute systems which have very low energy consumption, but which have very high performance, where the area, so the size of the thing, is as small as possible. You don't want the mainframe in your pocket. You want the performance of a mainframe in your pocket, but not the size of a mainframe in your pocket. Obviously, we care about cost and obviously also about the sustainability aspect of this. Now, is this really a problem? It is, especially for AI, the size of the dimension of energy and the dimension of sustainability is really becoming a problem right now. If you look at GPT-3, one of the early days large language models, which in the AI world is more or less a dinosaur because it's 2 years old, more or less. Building and training GPT-3 had the same carbon footprint of driving a diesel car to the moon and back to only train a single model. Right now we're in GPT-4, people are talking about GPT-5, and we're training multiple of these models at the same time as well. And it's not only in these large language models centralized, it's also in edge environments all around us. If you would, with today's technology, and with technology I really mean the combination of hardware and software, would want to have a fully self-driving car, 1/3 of your energy budgets actually goes to fueling the artificial intelligence of this. So it takes 1/3 of your energy budget to just decide on whether you would go left or right as well. So I think this shows how non-negligible AI and the compute behind it is from a performance and from a functionality perspective. We've been doing great things, but it does come with a compute cost and with an energy cost as well. And there's really a reason for that. This graph is a bit of a complex graph, but it actually shows from the 50s until now how big a neural network, the driving force behind an AI system, has been. And it's a logarithmic graph, so it means that if it goes exponential, it goes really, really exponential. What you can see is that until 2010, more or less, the size of the neural network, so the amount of computations we need to train such a neural network, more or less doubled every 2 years. And doubling every 2 years is great. We love that as from a hardware perspective, because it just follows Moore's law, and we're able to do this quite clearly. But since 2010, something really interesting happened. It was suddenly the dawn of a new AI era called deep learning. And now we're at a phase where neural networks are increasing with a factor 100 every 2 years. So that's exactly the reason why we have this problem. That's the fundamental reason behind it, why the AI compute on a self-driving car is so high, why the carbon footprint of a large language model is so high. So every 2 years, the complexity of these neural networks is growing at a factor 100. And from a hardware perspective alone, we're not going to be able to solve this. Moore's law is not speeding up, it's slowing down, actually. And if you want to do something, you will need to have a joint innovations really at the combination of software, at the architecture, and at new type of technology as well. Only with this combination, we're going to be able to keep this trend down at a certain controllable level as well. So what are we doing as IMIC on this? We're actually focusing very much on this fundamental problem, on trying to solve, on making sure that AI can really flourish, also not today, but in 5 to 10 years from now as well, that we can solve this energy and sustainability problem. And we're doing this on these 3 different domains. So on the one hand, we're looking at new semiconductor technology. We're looking at new low-power chips as well, with microwatts to watts of power consumption. And we're also coupling this with the actual algorithms as well. And here you can see a very simple example, but a very low-power AI example of how we're able to do gesture recognition with a factor 100 less energy than a state-of-the-art system for that. So this is what we do from the hardware side. But this goes really hand in hand with what Vivi was saying as well. In the future, we cannot just think that the hardware and the data privacy side are just 2 separate, isolated worlds from each other. We need to really bring them very close to each other. If we're going to evolve towards an environment where AI is not going to be in one single centralized data store, but it's going to be devices, every single device out there which will have AI, data privacy, and doing that at a very low energy compute cost as well is going to be key to make sure that AI flourishes and that we are able to get this right type of applications. So for us, these are 2 quite different worlds, but two different worlds that we very much bring together. We are doing research on personal data vaults through the solid technology. We're doing research on data spaces as well. And at the same time, we're also doing research on the hardware. And these two things really need to come together in an environment where you would build from a distributed environment where you would build really AI algorithms that run on a set of edge devices, but do this really at an energy consuming level as well. This is a quite complex slide, but the idea behind it is that you take the algorithm, you look at what is the best way to design this algorithm, both from a data perspective and from a compute perspective, and you're able to deploy it then in a sustainable way. And what would the end product look like? The thing that we're looking at a little bit is something that on the one hand looks like a privacy nightmare. It also looks like a compute nightmare, but at the same time, if we would be able to pull this off in this compute and privacy way, it would be great. Suppose that you would tomorrow would have a ChatGPT specifically personalized towards you. It knows exactly everything about you. You can actually ask it anything you want. It's your personal assistant. It knows what your favorite beers are. It knows what you're gonna eat tomorrow and what you ate yesterday. It knows who your friends are, when you interacted with your friends, and so on. It would be a great personalized assistant that you can actually ask anything about at any moment in time. On the one hand, that's great. On the other hand, it's also a privacy nightmare if you would want to share all that data with a centralized entity. But what if you would tomorrow would be able to build this system just locally in your own device, and where you're 100% sure that that data never leaves your own personal device, and that you never will need to share that with anyone else as well. If that would happen, I would immediately buy such a thing. But of course, from a compute perspective, we're not there yet, and that's exactly what we're trying to build, bringing these two worlds together. On the one hand, trying to get this data close to the end user, but also making sure that we have the right compute hardware to do this in a sustainable way. And we call this sustainable edge compute. Thanks a lot.
Cool, thank you. I think that you could take over and do my presentation as well. Just aside, so I'm Sessim, I'm the CEO of Open.
The mic.
Yes, okay. So I'm Sessim, I'm the CEO of OpenChip. OpenChip is a company that is focused on silicon design and software architecture and looking at the system level. And we are very much centric on how to enable technology from European perspective, right? And I think that what Vivi and also Steven talked about, it's very well connected with our mindset. And today I'm going to share a little bit some of the technologies or approaches that we are thinking about, and obviously like connecting with what they talked about. I think that one important aspect in terms of the technology is what Steve already talked about on what is the approach, right? So typically when you look at some of approaches in the ecosystem is, okay, I'm gonna be focused on design an engine for the car. I'm gonna be focused on the automatic gear and stuff like that, right? But the reality is that when you buy something, you buy a car. And that this principle, it's not only specific to car design or car manufacturing, it applies as well into AI and systems. And to kind of create products that comprehend everything that Steven and Bibi talked about, you need to have that at the system level design, right? And obviously you have the hardware level on the bottom that basically, as Steven said, it's what is going to be computing data, it's going to be training the neural networks, it's going to be creating models that then they run in your devices, they run on the cloud. But at the end of the day, this is just a means to an end, right? So the end are the models, so if you deploy a model in a manufacturing facility or you deploy a model into a healthcare facility or industry, they have different requirements. And you need to kind of design the final product looking at starting at the user level. And then you start, and when you understand the deployment model, you understand the requirements. Requirements can be performance per watt, can be data privacy, can be latency, depending on the use case. Now you start breaking down on what are the requirements that your system needs to satisfy, right? And when you think about the requirements, you start maybe at the silicon level, at the CPU, but then you start kind of building up on the pizza box that Raf was talking earlier at the beginning. And obviously that will depend, because one of the interesting aspects is that today, and actually this is one of the challenges that we have with Edge in IoT and Edge to Cloud, is that it's the problems or the use cases today are not anymore like monolithic, meaning that, okay, you have one application that is doing video analytics for safety in a city and runs into a central location in a cloud. That's not the case anymore. You have like one part of the application that runs on the camera, maybe another part that runs into a pizza box, into the street cabinet, and then another part that runs into the cloud, right? And each of these locations has different requirements in terms of security, in terms of compute requirements, and you need to think on the system design, not only at every of these points, but also collectively. And connecting to the point that Stephen was making in power consumption, like when we were back into the cloud days, you may have, like, I don't know, maybe hundreds, thousands of locations. But now, as you move into the edge to cloud, now you go into the millions on the edge, or billions on the edge. Now you go into the millions on-premise or data or data centers, and then thousands into the cloud, right? So now, if you look at not only at the because what Steven was mentioning, like going to the moon and coming back, is just the inference part of it, correct? Like now you start adding up, like all these elements at distributed level, and you go into a megawatt kind of consumption model that is huge. And just to give an example, so we were working with a European company that they had a deployment model that was consisting on 70,000 edge locations to do safety analysis on the road. And the original design was not considering the power aspect on, okay, where is the places that makes more sense to run my workload that is analyzing the traffic on a given point of time. And what happens to be is that that company had certain locations that they had green energy with the solar panels, right? And now, connecting to what he said on scheduling, now what we did is work with that company and say, okay, let's understand how your flow of energy coming from the green area and your brown area, and now try to make intelligence on where you compute the models, right? And with 15,000 of locations in 1 year and doing optimizations on how you manage the power and how you do the scheduling of the inferencing and processing, we saved about 70 million of euros of energy per year and 150 millions of kilograms of CO2 emission, right? And this is substantial. So that brings again the importance on the software and hardware and system co-design. Now, I'm gonna be focusing more on the data aspect of the system architecture. I think, like, we can, I mean, obviously we can maybe next year get deeper into the power, and as Stephen was saying, it's something that includes not only like the silicon, but also like the distributed nature of your systems. I'm gonna be focused on the data, okay? Because now connecting back into what Stephen was talking on the models, right? So fundamentally, and I liked what Evie said, is I think that in my opinion, like, we are in a little bit in a pseudo hype in generative AI. I think provides a lot of value, but my question is, we're in the point that you don't pay to, like, when my daughters, they are not using ChatGPT today, but they could use it to generate a video of a monkey dancing, whatever, blah blah blah, right? And the question is, today we don't pay for many of those things. But at the point that the CSPs, because that's a business, right? So at the point that you start charging for all these inferences that consume tons of energy, that require tons of training, are every one of us, it's going to pay for us? I don't think so. There are some use cases that they are like Copilot for developing code. It's extremely useful. There are some of these, 5 minutes? Okay, so then I will have to speed up. So I think that that's going to be a little bit on rationalizing a little bit the AI. So coming to the point, I think that the important aspect is on data, right? Because many of the models that we have today are assuming that you have tons of data that you use to feed them and to train them. And my question, and the question that we have to make ourselves is, okay, we're going to give all our data to train models for big companies for them to make business? I don't think so, right? And basically one of the kind of crusades that we personally have, and I think Steve shares and Raf as well, is how we can create technology elements that help us as Europe to protect our data while we have benefit of what AI provides to us, right? So Copilot or what Steve was talking about on this edge computer. So fundamentally, like from OpenChip, so we are kind of looking at, actually, let me go back for a second, just real quick. So we, sorry, okay, I think I'm going, how do I go back? The other one. This one?
Yeah, this one.
Oh, okay, that's tricky. I need AI for helping me out. Okay, cool. So about the boundaries, right? So we're working fundamentally on 3 things. So the first one is provide mechanisms so that the data can be protected at the source. Second is ideally the data should not leave the source. And third one is we should empower the citizens to control the data, right? And building on those principles, the first one is on the data poles that Stephen was talking about and Raf and the data utility company and working on is, can we have mechanisms that we empower the citizens to control the data and provide hardware mechanisms because, again, you can do software schemes, but you need hardware to guarantee some of those data as we're using today for security, for example. So can we do that, right? And the fundamental aspect that we are not sharing it here is, I think that there is a need for European governmental institutions to provide us some mechanisms so that they provide infrastructure. Because, I mean, connecting to what Stephen shared on Apple, right? I mean, it's wonderful that you say that you're going to be protecting my data, but do I trust you? No. So who do I trust? So we need an interlock between software, hardware, and the politicians and the governments that they provide public infrastructures that basically are interfaced to the hardware and the software to protect that data. The second aspect is on the data should not leave the source, right? So the other aspect that we are trying to understand is, can we do some level of training of the data in the hardware itself without exposing the data to the software, right? So that's, I don't know if you guys are familiar with Secure Enclave, but there are some technologies that are being proposed to kind of protect the data and expose some properties of the data to the software stack. And that's another area that we're kind of working and trying to understand. And sorry, guys, I'm rushing a little bit, but just to be cognizant on the time, and happy to continue afterwards. But basically, the last point, which I think it's on the federated and the federated training, right? And what is called differential privacy. We have technologies today that they help to kind of perform learning and training at the far edge without crossing certain boundaries. Now the question is how ready, like, our infrastructure and our software and hardware technologies are ready to do that, right? So I think, and again, connecting back to this public kind of public-private co-design, to make this type of technologies that help to train models without crossing boundaries, preserving data privacy, we have techniques that we know that they work. We know how to train models in a federated manner without crossing boundaries. Now the question is, how do we make this system architecture that is highly distributed effective and accessible to all of us, right? And I'm going to close here, but basically my messaging, and I think that we will concur, is that data is, in my opinion, from AI, I mean, we know how, or we at least, I think that we know how to address power. But when it comes to the data, I think that there is a lot of work that needs to be done here in Europe. Second, it has to be at the system level, what he said about, Stephen said about software and hardware. You can't make systems or data protected just by software. You need to have hardware in place. And the third part is, I don't trust companies, even my company, to control my data. Seriously. So we need to have this kind of three pillars to kind of develop AI for Europe, right? So. Sorry about, I took a little bit longer probably. No, perfect, okay, good.
Thank you, Cesc. So, thank you for the stunning presentations, and we are looking forward to your questions. Do you? Ah, yeah, everybody can use his own mic. Are there any questions, remarks, or insights? Yes.
Red? Okay. Hi, everyone. Well, thank you both, Vivi, I don't know where she is, for these great presentations. What you said before, it reminded me to one project in which I was advising for in 2016, 2017, about having a sort of app or solution that actually knows everything about one person. Obviously, as you can guess, those years before, even for the pilot, it was pretty challenging to get people to participate to see whether the pilot would work. From a privacy perspective, a lot of challenges. But I thought it was very interesting from the positive views, because the main goal for that platform was to help people to avoid commit suicide. And then they saw the value of the data that could actually work for many other positive outcomes. But when we were analyzing all of that project and the challenges that legally we were facing from a human-centric point of view, and to try to comply with all the principles that nowadays have become law under the EU AI Act, we still don't have full responses for all of these questions. So I like the model that you mentioned in terms of everything in one site. I don't think we are ready yet, and I think we are more in a model where we have different sites and different data spaces with different requirements to deal with these sort of very high risk profiles. And I also agree with you, if that solution is trustworthy, I will also join as well as a participant. But yeah, this is a pilot that for now, it's not coming to light, because after 4 years, we still are facing legal challenges that are stopping that to happen. So I wonder whether you were any views on how we could this could become a reality. Yeah.
Thank you. First of all, I fully agree. I think this is more of an end goal. So this is where we could dream of that we would have in the future. Is the technology there yet to do this? No. Is the legislation there yet? Probably also definitely no. But I think this could be a kind of milestone or a dream that we could go for. I think it's also important that technology will always provide new chances, will be on the one hand disruptive towards legislation, but will also try sometimes provide new opportunities to have a better legislation as well. And if you would, from a technology side, be able to give really 100% guarantees on the data privacy part, I think from a legislation part you can do much more. It's like what Cesc said. You need to be in a level where you you're not able to trust either the company who's delivering that device or that algorithm, but that the technology is in place, that you do have enough trust, that even if you don't trust the company, that it is there. So it is more of a dream to go to. I think a lot of the puzzle pieces are already in there, but the only way to achieve this is by really having this hardware-software interaction as well. You can get a lot of control on your data, but if you tomorrow share it with a party that you don't trust, it's gone. You can do a lot on the software level, but if the software can be hacked, it's gone. So you need that interaction all the time as well. Only then, if you have enough measures together, you're able to get full trust. It's a bit of a layered cheese approach. Software will have some holes in it. The hardware will have some holes in it as well. But if you put enough layers of that cheese together, you can get to 100% guarantees on trust.
Yeah, and that makes sense as a dream. It would be perfect because as you were saying that, I was thinking all the legal issues that I was discussing a couple of days ago with another professional here with regards to the responsibilities and liabilities within a general purpose AI context and to high risk AI context. If that infrastructure is that secure and that it can guarantee, can reassure, I can tell you that that conversation would be like the 80% of the issues would be gone. So that makes all the sense. Thank you very much for your input.
Yeah, maybe as a small comment related to this topic. I mean, not in the context of AI, but today, if you look, there are some technologies, like, for example, TPM, which is Trust Platform Module, that basically is something that became a standard way that when a server or a computer boots, it can connect to a central place and say, yes, I'm looking at all my stuff, I can securely boot, I can trust all the software that is in my system, right? And this is today a standard way that most of servers are using to kind of trust the stack that they have inside the hardware. If you look at from AI perspective and all these topics, I believe that technology can be defined in a similar way. And for me, one of the key aspects in connecting into the legislation, I mean, sometimes when you do project, it's like, damn it, I have to satisfy this, and this, okay? And then at this time, I kind of blaming. But when you think with perspective, right, I think that this is good because that enforces that. I mean, I will go beyond hardware, software co-design. I think it's system and legislation co-design. Because I think that one of the challenges is that if you legislate and you don't know how to actionate that legislation, it's going to be a miss, right? And that's where I think that if we can couple the two of them, the challenges that you were facing probably are going to be easier to address because you will have technology that has been designed at the same pace and connected to the legislation, right? And hopefully, if we go down that path, maybe the utopia, what he's sharing, maybe it's closer.
Yeah, thank you so much. That was very insightful. Thanks.
Maybe just to add, I think I fully agree with that. I think that Europe is sailing its own course, is providing additional, indeed, as Ralph already said as well, with the Data Act, with the AI Act, is providing additional levels. But I think that also is a huge business model opportunity for new organizations to jump in and to start already from that human and trustworthy aspect of what Europe is defining and making sure that the AI systems are designed with that upfront from day one. And I think that's not something that you will see today in the current ChatGPTs of this world, but you could see in the future as well.
Thank you for your question and the insights. Are there other questions or yes?
So this was one. My name is Georg Neuber from Austrian Institute of Technology, dealing there with digital safety and security. And I think it was in the presentation of Professor Lattre, but I'm not pretty sure. You mentioned that the footprint, the carbon footprint of AI-driven car, is this similar to a diesel-driven car? Or did I get it right? What was the message exactly?
Was that if you want to have a regular car and you want to make it self-driving tomorrow, so suppose you would suddenly attach an AI system to it, 1/3 of the power budget of that car in the inner city would go to just running the AI model itself. So 2/3 would actually go to making sure that the car moves. Okay. 1/3 goes to just thinking about, should I go left, right, accelerate, braking.
Okay, thanks. That was quite interesting.
There are also questions from the online audience, but we are going to fix the Slido and bring it onto the screen.
Yeah, my question, I also posted it online, so maybe it might be the same. I was wondering, currently I'm working for mainly for companies, and the citizen is not my client, so they pay for gathering data and processing it, etc., and you can do it completely according to the law. But citizens in general are not the customer. So, and you later on said how much that you would want to pay for a personal assistant that is private proof. So how much are you willing to pay, let's say on a monthly basis, for such an AI assistant, knowing that there are free assistants that are nudging you to buy and consume as well on the market?
Nothing is ever free, so you pay with privacy in that
Exactly.
in that context. And I think that going forward, you see more and more that both privacy and sustainability is going to be a very important business model as well. It's not that easy anymore to say from iPhone 15 to iPhone 16 or from iPhone 16 to 22 or whatever, you're going to have a better camera or a better whatever. You do see the shift that, and Apple is doing this very clearly as well, just with their latest announcement as well. We are the most privacy-aware company. That's at least what they're trying to put in the market. Whether you trust them or not, that's another ballpark. But you see that privacy and sustainability is becoming the reason for customers to buy a certain product going forward. So I'm not too worried about that. I think we do see a changing reflection in society as well, that people are understanding more and more that nothing is free and that you indeed pay by giving data away. And still your choice then to go for that or not. I happily pay for a more paid ChatGPT version if I'm sure that my data doesn't get leaked. And it's also a business perspective. In the very early days of ChatGPT, there was a leakage of, for example, of Samsung officials who put documents into ChatGPT, which was then trained again in the model. This just shows that the privacy issue is a challenge there as well.
I may be a little bit controversial here, but I like controversy. So I think your question is very valid, right? And I think, there's one aspect which is about educating the society about what privacy entails, right? And I think that today, when you go in sustainability, people understand that when you burn fuel, you are, polluting the atmosphere at the expenses of your health, right? And now ways to kind of address that issue, like governmentally, you add taxes into the fuel, or this type of thing, or promote sustainability as one of the KPIs that as a society, as Stephen said, it's important. For me, privacy, it goes along the same lines, to be honest. I think that there will be a transition period where we need to educate and tell people, make this kind of mentoring about why privacy is important, right? And maybe going a little bit extreme in some cases, and okay, if an insurance company has access to all your record, and then at some point they will charge you more because of the probability or likelihood you for having X, Y, and Z. I think that these are some of the reflections that maybe 1% of the population does at some point. And I think that again, this public-private kind of marriage has to happen, and probably it's not, I'm not going to pay less or pay more for security. I think that has to be, at the first instance, supported by the politicians and governments, which are kind of dictated to help and protect the society. So my two personal sense.
Okay, thank you. Let's very briefly address the questions from the online audience. A question that's not on the screen anymore was like, let's produce a lot of green energy and the problem is fixed.
That's the same thing as saying, let's add another lane to a road and we won't have traffic jams anymore.
Thank you very much. So, yeah, and question from the audience?
The question is on the screen now, and I like the contrast between the two first questions. We've focused a lot on the trust and the privacy aspect, and we rely a lot on that citizen to do the right thing. But unfortunately, since COVID and the latest years, I've kind of doubted that trust that I have in that individual to make the right decision. And so I wonder, it's a conflict in my head, what is the responsibility of the government to also to protect their citizens in a certain way? But then I like the fact that both questions are now on, but can we trust all types of government? And it's really conflicting for me.
It's a great question. I don't even know how to protect my data, to be honest. Like if I open my Chrome or my Safari, every time I get weird questions about you accept, reject all and everything, right? So it's a very valid point, and I think that's a little bit like these are the type of the right discussions that have to happen now. Yeah. In my opinion, I don't have a clear answer. I don't know if
maybe also a small reaction to that. I think today there's a huge chasm between the initiatives, the good initiatives of the Commission on the level of the new legislation and how to implement it. We saw this with GDPR, which was a good move from Europe, but companies were struggling in Europe to implement it. And I think with the Data Act, it will be even worse. So I think from a technological perspective, together with those who make the laws, we should come up with like a blueprint for an architecture, how you can create edge devices which are maintaining data sovereignty. And I truly think that it's not the government that needs to manage that data, but the government can help to create, together with academia and industry, to create a framework where we can come to a moment that we have this more resilient and data or privacy preserving infrastructure. And then you can combine it with the other question, like we click a lot yes, yes, yes when we are asked consent for cookies. Can we expect citizens to manage their consent, or isn't this going to be a move from the data to the consent hell? Well, I truly believe that new initiatives will evolve. Today we see a lot of new initiatives which tend to be like data unions, where I can outsource my consent to an organization that I trust, that has the values that I have, and that will help me with my consent. So if we have the right legislation in place, if we have a blueprint on how to develop devices which are in line with those principles, new initiatives will arise that will support citizens, and it won't be from the government, but there will be citizens' initiatives like data unions.
Yep. So I have maybe it's a simplistic and provocative question, but I feel that with data, with personal data, we're trying to, so the problem is not others are having our data, the problem is what they do. So it's like having a knife. Having a knife could be dangerous, but useful as well. So I guess that as long as we don't have methods for controlling what they do with our data, we are preventing to use the data at all, or imposing high restrictions, but it's also imposing restrictions to some developments. And other parts of the world are not like Europe, and they are somehow profiting out of this. And regarding what you mentioned, click, click, click. I consent that my data will be sold to the Chinese government for do whatever they want. And we click, 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 click. So,
but these evolutions, I think, it's about choice. Today, my data is in the silos of the GAFAs and the GAMAs. I don't have the choice either to share it with them, to not share it with them, to share it with stunning new companies in Europe that wants to make my life cheaper, healthier, more consensuous. I don't have a choice, but by putting citizens in control of your data, you have the choice.
Yes, but at what cost? So I don't have a clear view, but I have concerns that we are only seeing the problems and not seeing the advantages. And maybe in the advantages there are something very profitable, even for our sustainable, for our health, for many things. So an example, let me put you. There are cooperatives for gathering data about rare illnesses because they don't have it. And there are the users who have to share the data because there were so many restrictions on health data that their illnesses cannot be studied. So somehow this protection for health records is preventing some illnesses to be studied and solved. So, sorry, I would like to say, this is the question. My point is just to reconsider what are the balance between one thing and the other. And unfortunately, I don't have a clear view what should be done.
Maybe just two quick sense. I think that your point is like kind of the philosophical, not question, but kind of a statement makes sense. I think, though, that, like, for example, in the healthcare domain today, when I was talking on the federated learning, like in Spain, like, for example, there are different hospitals that they are keeping the data within the hospital and applying federated learning to kind of improve models that are actually used for predicting likelihood of cancer, right? And there are models that I believe that if we find the right balance between protecting and exploiting the data, and we provide the mechanisms for the different use cases to kind of get the maximum benefit out of the data while protecting the kind of the end users or the citizens, I think we have those. But I think it's important. To your point, I think you're not talking about the technology, you're talking about the use case and the use of the data for a particular purpose. So I think it's very important that we don't start from the technology, we start for the use case and the use cases that are needed. And based on that, you derive the system that you need, right? So, and maybe that's the way to start.
We can have one last brief remark. And sorry, Steven, yes?
Maybe just to add a little bit, I think you're absolutely right that it is a balance. And I think for some cases, it's very important to share data. For other cases, it is not. And to Cesc's point, indeed, technology can help as well in even solving that balance. But we should also be really careful. I think the use case you mentioned is a very interesting one. Because what you see in that direction, maybe I'm going to derail the discussion a little bit, but for example, at IMEC, what we're doing is we're developing a chip that is allowing you to do protein sequencing. Protein sequencing is mainly the next step after DNA sequencing. It allows you to take a swab, put it on a chip, and immediately out of that comes, after a bit of AI, comes a whole list of the type of diseases that you would have before you would even get this on a radiology image whatsoever. That's a type of environment that are the ChatGPTs in 5 to 10 years from now, where you take a swab, you send it to somewhere, to where? The GAFAs of this world, maybe, who will do this analysis for you, and they will know that a full list of diseases that you have before you even know it. That's the type of use cases where there's absolutely a balance to be found, because you need that data to be able to detect it, but you also need to protect it. And I think technology can go a long way into that as well. So I don't think we should advocate for saying keep all the data here and let's not leave it, but just make sure that you can have that control as well.
Okay, thank you. So I would like to thank you all for attending this session, for your questions and remarks. We are open for collaboration, still developing this initiative. I would like to thank our speakers, Vivi, Steven, and Cesc. Thank you very much.